Okay, today's lesson is on rotations, which is a very important lesson with a lot of little details that you should pay attention to, okay? First, quick review of the rotation rules. All right, remember that a 360-degree rotation puts you back at the same spot. All right, so that's why the coordinates stay the same. XY becomes the same, XY. 180-degree rotation, the rule is similar to 360, because the X and the Y stay in the same spot, but you got to change them to the opposite sign, each one of them. Okay? And then 90 and a 270-degree rotation are related in the sense that for the rule, the X and the Y's switch places in both of them. Now, the way I remember it is that 90 goes before 270. 90 comes before 270. So in the 91, it's the first one that you got to change to the opposite sign. And in the 271, it's the second one that you have to change to the opposite sign. Okay? Now, on this slide, we just got to look at two important terms. Angle of rotation and center of rotation. The angle of rotation is how many degrees do you rotate the figure or the line or the dot. All right, so like in this example, the angle of rotation is 110 degrees. And when you rotate a figure or a line or a dot, the distance will always remain the same from that point to the center of rotation, which is our other term that we have to go over. The center of rotation is the point that you're rotating around. Okay, the center of rotation is the point that you're rotating around. Now, in most problems, you're just rotating it around the center of the coordinate plane, around the origin, 0, 0. But you will have some problems where they'll give you a point and they ask you to rotate it around it, which we'll look at that in 1 second here, in one moment. Okay, now, so far, all the types of rotations that we've looked at or that we've talked about, they're all counterclockwise. Counterclockwise. So if you look at this photo here, counterclockwise means to the left. Counterclockwise is the direction opposite of the clock, so going to your left. But today, you are going to see some questions that are going clockwise to the right. Okay, so let's talk about that real quick. Let's say I have you. Let's say there's a. Let me write this here. Let's say you do a rotation of 90 degrees. All right, 90 degrees counterclockwise, which is this way, 90 degrees. Okay. What I want you to realize is that 90 degrees counterclockwise is the same as 270 degrees clockwise. So going to the left 90 degrees is the same thing as going to the right 270 degrees. How did I figure out that 270 degrees? All I'm doing is 360 minus 90 degrees, which gives me 270. All right, so if you go to the left, you could also go to the right and get to the same spot by doing 360 minus whatever this number is. Okay, so just to give you another example, if you go to the left, if you go, let me stop saying to the left. If you go counterclockwise, and let me use I don't know, an easy number. Try to use an easy number. 120 degrees counterclockwise. That's the same as going clockwise. Just do 360 minus 120. Okay, that would be the same as going clockwise 240 degrees. So 120 degrees counterclockwise is the same as 240 degrees clockwise. They both put the figure in the same spot. They both end up in the same spot. Okay, now why am I bringing that up? Because you may have questions where they rotate a figure and it's multiple choice. It'll be multiple choice and they're asking you to pick the right answer. So let's go back to this example right here. Okay, let's say we have this example right here and they rotate the figure and it's obviously a 90-degree rotation, but you look at the multiple choice and 90 degrees counterclockwise rotation is not one of the possibilities for the answers. However, 270 degrees clockwise is one of the answer choices. You have to realize that that means the same thing, that it's going to get you to the same spot. All right, so in a situation like that, that would be the answer, 270 degrees clockwise. We'll look at some questions like that in a moment. Okay. The other thing I wanted to go over is that you could actually do rotations greater than 360. Okay, so for example, let's say that you do a rotation of let me think here, 450-degree counterclockwise rotation. All right. So let me tell you what that means. All right. First of all, we all know that 360 degrees is a circle. So pretend I'm starting right here where this A is. If I do a 360-degree rotation, that means I'm back where I started. So a 450-degree rotation means that you first do the entire circle 360, and then you keep going 90 degrees more. All right, so a 450-degree counterclockwise rotation would put you in the same spot as a 90-degree rotation counterclockwise. All right, because once you go 360, you're back where you started, and then you got to go an additional 90 degrees. All right, just to make up another number, let's say you do an 800-degree. Again, there's a question like this on the homework, and they do come up. All right, and I just made up that number, so 800 degrees counterclockwise rotation. Okay, so first of all, we know that 360 puts you back in the same spot. And if I do 360 again, if you look up here, 360, if you multiply 360 times 2, that's multiplication. All right, you're going to get 720. So 360 puts me back at the same spot. 360 again, which is a total of 720, I'm back at the same spot. So if I subtract those numbers from 800, I'll see that what I really did is just an 80-degree, like the end result will put the figure at an 80-degree counterclockwise rotation. All I'm doing is subtracting 360 and then subtracting 360 again until I can no longer subtract 360 because the number that's left is less than 360, and that tells me what the rotation is actually going to be in terms of where's the point or the line or the figure going to end up at. All right, I believe there's a question like that coming up in a second here. All right, so look at these examples of what you're going to have on the homework, and these are the types of problems that you're going to see a lot, right? I put the rules here so that we could easily see them. It says that we have to rotate this figure 270 degrees, okay? Now, if the question does not specify counterclockwise or clockwise, it's always counterclockwise. So again, I'll say that again. If the question does not say whether they want you to do it counterclockwise or clockwise, that means it's always counterclockwise. If they want you to do it clockwise, they'll say it. They have to say it. Otherwise, it's understood that they mean counterclockwise. All right, so rotation of 270, here's our rule. For a 270-degree counterclockwise rotation, there's a rule. X and Y switch places, and the X, when you put it in the back, you got to change the coordinates to the opposite sign. So if you just look here, that's all they're doing. They're taking the coordinates of the pre-image, they're switching their places, and when you put the X coordinate in the back, you got to change it to the opposite sign. 1 becomes -1, 4 becomes -4, 3 becomes -3. And you graph it, and that's it. You're done. All right? That's simple. Just follow the rule. Look at the rule. All right, let's look at another example here. Okay, so here we got to do a 180-degree rotation. Okay, so again, we look at our rule, which you should have hopefully start memorizing. XY is going to become -x, -y. So first, let's get the coordinates. All right, so they're giving us the coordinates of the pre-image here. Okay, so they're going to become -2, +1, -4, +1, and -1, +4. All I'm doing is getting these numbers and changing them to the opposite sign. +2 became -2, -1 became +1, etc. Okay. Right here it says the rotation image of x comma y is. Oh, they want you to write the rule here. All right. So again, I got this from the book, and on this page the rules were not there. I just added it for your convenience. All right. So they're just asking us to write the rule on the top to make sure you know what you have to do. All right. So the rule is this. Okay, now when I graph the new points, okay, k prime is going to be at -2, +1. L prime is going to be at -4, +1. And M prime is at -1, +4. All right. So it says predict the quadrant in which the image will lie. Since triangle KLM lies in quadrant 4, okay, if you forget, this is something easy to remember, so you shouldn't forget. But I told you the easy way to remember, because I always try to come up with little techniques like this, is think about the way you write the letter C. The way you write the letter C is you start at the top right box and you go one this way, this way, this way, and this way. So that would be one, quadrant 2, quadrant 3, and quadrant 4. Very simple to remember. So the pre-image is in quadrant 4, and once you do a rotation of 180, the image will lie, in this case, in quadrant 2. Again, this is quadrant 1, 2, 3, and 4. Okay? Hopefully you realize that that's very simple. All right. Look at this question. I put the answer there because this question is on your homework, but it has a different number here. But this is what I was trying to explain earlier. Uh, it says, suppose you rotate quadrilateral ABCD in part A by 810 degrees. In which quadrant will the image lie, and explain? All right, so if we go back a second to the picture in part A, all right, whoops, that's not it. Here we go. All right, that image, the pre-image is in quadrant 1. The pre-image is in quadrant 1. Okay, and the question is what quadrant is the shape going to end up in once you do a rotation by 810 degrees, all right? So first thing to do is, we already know that 360 rotates it back to where we started. And 360 again gives you a total of 720 degrees. So if I do a 360 rotation, we're back to where I started. If I do a 360 rotation again for a total of 720, I'm also back to where I started. Okay? So a rotation of by 810 degrees means I'm doing 720, which puts me back in the same spot, plus 90 more, plus 90 degrees more. Because 720 plus 90 degrees more is 810, which is what they're asking me up there. Okay, and 720 just puts me back in the same spot. So the question is, and let's go back to the picture. I should have put it on this slide, but I didn't. Sorry about that. All right, so back to this picture. If we pick an easy line, all right, like let's say we pick that line, all right, and you rotate that line 90 degrees, that means the shape is going to be more or less like somewhere. It's a little hard to draw, but whatever. Something like that. But basically, if you rotate it, 720 is twice around plus 90 more. It's going to be in this quadrant. Okay. Almost always, like if you rotate it 90 degrees, it's going to put it in the next quadrant. 90 degrees more is in this quadrant. 90 degrees more is in this quadrant. All right. So it's asking us to rotate 810 degrees. Again, 360 is back here. 360 again, we're back here again for a total of 720 degrees. 90 degrees more would put it right here. All right, so if we go back to that question, all right, the rotation, a rotation of 810 degrees is equivalent to, look right here, it's equivalent to a 90-degree rotation counterclockwise, and it's going to put the quadrilateral in quadrant 2. It's going to put that quadrilateral. A quadrilateral just means that it has 4 sides in quadrant 2. Okay, so I'll do maybe 1 or 2 more of these, and then I'll move on to the other types of problems that we have. Okay, so in question 7, they want us to do a rotation of 90 degrees. Again, notice it doesn't say counterclockwise or clockwise. If it does not say, that means we always assume, or it means that you have to do it counterclockwise. In order to go clockwise, they have to specify that they want you to go clockwise. All right, so the way I recommend that you do it is just, this is how I recommend that you write it out. The most efficient and accurate way to do it, in my opinion. All right, so I'm going to write up here 90-degree rotation, and I'm going to put the rule underneath it. okay, which is that. And I'm going to put a line. Alright, so first I'm going to write the coordinates for the pre-image. Alright, so P is at 2, 1. Q is at 4, 1. And R is at 4, -3. Now I'm going to put my arrow, and I'm going to put P prime, Q prime, and R prime. Okay, now the reason I set it up like this is because now it's easy because I could just look right here to see what I have to do and catch any mistakes that I make. Alright, so alright, this is telling me the X and the Y coordinates switch places, and the one that you put in the front, you got to change it to the opposite sign. So it's going to be -1, +2. I forgot to put the parentheses here, but okay, this one's going to be -1, +4. Let me just go like that. Okay, and this one's going to be +3, +4. Okay, now let me graph it and make sure that that looks right. Okay, so P prime is at -1, +2. Q prime is at -1, +4. Okay, and R prime is at +3, +4. 1, 2, 3, 4. Okay, so notice something. Okay, I mentioned this in a previous class. Okay, that if we look at an easy angle to analyze, for example, this line right here, line PQ, okay, we know that if we rotate it 90 degrees, PQ would have to end up like this, and it does. All right, and that if we use that side as our guide, that shows us that, oh, okay, so on the top, because if we're rotating it 90 degrees, on the top should be side QR, and it is Q prime R prime. Okay, and then this horizontal side, or this, my bad, this slanted side should be right here, and it is. Okay, so yeah, that's the correct answer. All right, I'm gonna do one more like this. All right, this one asks us to do a 270-degree rotation counterclockwise. All right, so here's our rule. So again, let me set it up the same way. Let me set it up the same way. So on the top, I'm gonna write again, I recommend that you write it like this, and it'll help you avoid a mistake. Trust me, I've seen many mistakes, and I'm telling you, this helps you avoid it. All right, I'm going to write the rule underneath it. All right, so I got this. Here's the rule. All right, so first thing I'm going to do is write the... I should have looked at the letters, huh? All right, let me try that again. Okay, first thing I'm going to do is write the letters here for the pre-image, D, E, F, G. Alright, so D is located at -3, +1. E is located at -1, -1. Okay, F is located at -1, -4. And G is at -3, -3. Now let me put the arrow. And let me try a different color here to make it easier to see. Alright. Okay, so now I'm going to do D prime, E prime, F prime, and G prime. Alright, so again, by writing the rule here, it makes it real easy because I could just look right here. And trust me, later if there's a mistake, it'll be much easier to catch if you're writing the rule right above it. I promise you. Okay, so the rule is telling me the X and the Y switch places. And when I put the X in the back, I got to change it to the opposite sign. So -3 becomes +3. Okay, on this one, this -1 will become +1. On F to F prime, it's going to become -4, +1. Okay, and G to G prime is going to become -3, +3. I promise you, as you're trying to do them kind of quickly, as I was kind of trying to do it kind of quickly right now, it's easy to get confused and mess up the wrong one. So that's why I'm telling you that if you set it up this way, it'll make it much easier for you to catch your errors. All right, so let me graph this. D prime is at 1, positive 3. E prime is at negative 1, positive 1. F prime is at negative 4, positive 1. And G prime is at negative 3, positive 3. Oh, whoops, sorry. Let me try to fix that here. All right, so G prime. Now I connect the dots. Okay, so let's look at this a second. All right. Again, if you want to like kind of see did I do this right? Let's look at this a second. Okay, let's look at this. I was looking. I was taking a while there to look at which side should I choose to kind of concentrate on. All right, let's concentrate on this side 1 second. All right, side DG. Okay, so if I do a 90-degree rotation of this shape this way, counterclockwise, side DG is gonna be. I'm just gonna write it wherever, guys. All right, but it's gonna look something. It's gonna be like this. Then if I rotate it 90 degrees again, side. You know what? Let me just to make it easier so that we're on the same page. Let me put DG here. That would be a 90-degree rotation. Okay, if I rotate it 90 degrees again, it's going to be something like this. Here's D and here's G. And then 90 degrees again would put the D and the G like that. Okay, and it's putting the shape not really up. Well, it's kind of hard to explain in words, but if you, this is something that in class I would be able to like cut out a shape. If you cut out that shape and rotate it 90 degrees, 180, 270, you'll see that it'll end up like that. All right, I'm just trying to give you different ways to visualize so that you could double check, did I do this right? Another way to double check is you could look at the, for example, side DG, it's an easy one to get the length because it's vertical. And you could see that the length is 4 units. So then you could look up here since it ended up horizontal and also get the length quickly. It's also 4 units. Same thing with side EF. It's 3 units long. So if I look at this one, E prime, F prime is also 3 units long. Okay, and I'll display the correct answer here so you can see that I was right. All right, in case you doubted me. All right, so let's continue. All right, I'm not going to do these because it's the same thing, but I'll upload the PowerPoints and also, it's also in the video in case you need additional examples. All right, let's talk about this part. Okay, you're going to have questions that ask you to do a rotation around point P, all right, and you're gonna have to pick which picture is correct. Okay, now listen, I expect you to do this without measuring it, without using a protractor. The answers should be obvious, like they're not gonna be so close that you need to measure it. All right, at least they shouldn't be. All right, you're supposed to use basically common sense by looking at it and figuring out what it should be. Okay, so like look at this example. Pretend the problem is right here, and they're asking you to figure out how much is this, how much is the pre-image, what is the angle of rotation of the pre-image basically to get to the image. All right, now the answer is obviously right here, but if you look at that, you can kind of see like if you concentrate on side AD, that it's a little bit less than 90 degrees. All right, so again, if you concentrate on this side right here, which is horizontal, if I rotate it 90 degrees, it would be perfectly like that, but it's not. It's a little bit less. So it's got to be something slightly less than 90 degrees. The questions are going to be multiple choice, all right? You're not going to come up with this. The questions are multiple choice, so you just got to pick which answer is a little bit less than 90 degrees and makes the most sense. Okay, in this question, it would be an 80-degree counterclockwise rotation. Okay, this would be the correct answer, and over here they're just writing that that's equivalent. This is what I was mentioning earlier. That's equivalent to a rotation of 280 degrees clockwise. All right, so again, just to reiterate this in case anybody needs further examples, doing a rotation 80 degrees counterclockwise, that's the same thing as doing a rotation of 280 degrees clockwise. And how do I know that? Because if I just do 360 minus 80, I get 280. So that tells me that if I go 80 degrees this way, that's the same thing as going 280 this way. Because when I add those two numbers up, I get an entire circle, 360. You are going to see some questions like that. You are going to have questions where, again, I said it earlier, where, like, let's say this one, where maybe you don't see this as one of the answer choices. So you got to realize that that means that this would be the answer choice. If they're not giving you this answer choice, you got to realize that this is the same thing. And if this is one of the answer choices, you would choose it. If by any chance they give you both, then they're both right. I mean, it's possible you may see that on a test or something, but okay. So this one, I'm just gonna display the answer because like I said, on the exam, not on the exam, on the homework, it's gonna be multiple choice. All right. So again, as long as you have a rough idea of where it's going. All right. This one, we're starting here with our pre-image. We're starting here with our pre-image, right? And we're going to here to our image. All right, so look, I haven't, even though I put this together, I haven't looked at the answer right now so I'm just gonna do this off the top of my head. You could either choose this side to concentrate on or this side. All right, but I would say, okay, let's look at QR. If I rotate it clockwise to the right, QR would have to be like this if I do a 90-degree rotation. QR, let me write QR. So this would be 90 degrees. If I rotate it 90 degrees again, QR would be like this. Right, for a total of 180. So as you could see in the picture, it's between those Q prime, R prime ended up between 90 degrees to the right or 180 degrees to the right. Or I should say 90 degrees clockwise or 180 degrees clockwise. It's something in between that. So if the answer is going clockwise, it's got to be a number kind of in the middle of 90 and 180 degrees clockwise. Okay, in the middle would be approximately, like, I don't know, 130 degrees maybe. Something around there, 130 degrees clockwise. And if I go counterclockwise, I could just do 360 minus 130, and whatever that gives me, 360 minus 130, which would be 230, it would be something around there. So either approximately 130 clockwise or approximately 260, I think I said, counterclockwise. All right, let's see what the answer is. All right, so they're going clockwise, and as you can see, my guess was 130 clockwise, and that's what they put here. I believe in situations like this, they're going with the lower number of the two. So what I mean by that is, like in this case, I was saying that it could be 130 clockwise or 260 counterclockwise, and they're going with the answer that is the lowest rotation, the smallest rotation of the two. So in this case, since it would be quicker to get there by going clockwise, they're putting the answer as 135 degrees clockwise. All right, just to look at another one, I believe we're almost done. Here's my center of rotation. Here's my pre-image, and here's my image. Again, I'm going to try to find the easiest side that I can concentrate on. I mean, depending, different students may have different opinions of what's the easiest side to look at. I'm going to choose, I don't know. Let's go with this one, I guess. Side NM. Okay, so again, if we go with the quickest way to get from here to here, the quickest way would be clockwise, not counterclockwise. All right, so let's try to look at it as going clockwise. All right, if I rotate side NM 90 degrees, you use easy numbers, 90, 180, 270. Let's do it in think about it in groups of 90. All right, so the first thing I'm going to check is if I rotate this 90 degrees, NM would be something like that, right? Or I should say N prime, M prime would be something like that. N prime, M prime. So look where it is here. All right, I'm saying that N prime, M prime would be something like that if I rotate this side 90 degrees clockwise. Okay, and it's a little bit less. Or not a little bit, but maybe, I don't know, 20, 30 degrees less. It doesn't quite make it. It's less than 90 degrees clockwise. All right, so my guess would be something around 50 or 60 degrees clockwise. 50 or 60 degrees clockwise. So let's see what the answer is. All right, I was kind of close. It's 70 degrees clockwise. 70 degrees clockwise rotation. Again, the multiple choice answers, there's only going to be one. There should only be one that's in the vicinity of the correct answer. The other three answer choices should be definitely off so that it'll be obvious which is your correct answer choice. Okay, and this is the last type of question that you're going to do, which is Well, I'm sorry. There's these, and I gotta go over one word problem, and then we'll be done. Okay, and I gotta speed it up here. Okay, so this one you gotta write the rule of what's happening here. So look, just pick 1 or 2 points. For example, point D is located at -4, +2. Let's compare that to D prime. Okay, D prime is at +4, -2. That's probably enough to write the answer, but let's do one more. G is located at -3, -4, and G prime is located at +3, +4. All right, that's enough for us to write the rule. The rule has to be, I'm going to write the rule like this. Okay, the x and the y are staying in the same place. So my rule has to look something like this. The x and the y are staying in the same place. However, the x's are changing to the opposite sign. So I got to add that negative sign. And the y's are also changing to the opposite sign. Okay, so that's the rule. And if you look at the rules, that's a 180-degree rotation. All right, so that would be my rule, and that's a 180-degree rotation. Just to do another one quickly here, and since I'm in a rush, I'm going to do just 1 point. R is at -4, +3, and R prime is at -3, -4. All right, so that means that this is the rule. Okay, XY is being changed to, okay, the 4 and the 3 are switching spots like that. Okay, when you put the 3 in the front, it's changing to the opposite sign. And when you put the X in the back, it's staying the same sign. Okay, so that would be the rule. And because I have my rules memorized, that's a 90-degree rotation. Because remember, 90 degrees, they switch spots, and the first one changes to the opposite sign. And the last one I have to go over is this one. This comes up, I believe, on exams. Okay, a Ferris wheel. This is a Ferris wheel. It has 20 cars that are equally spaced around the circumference of the wheel. The wheel rotates so that the car at the bottom of the ride is replaced by the next car. By how many degrees does the wheel rotate? In other words, if you have a Ferris wheel, how many degrees does it need to rotate so that this car is replaced by the next car? And there's 20 cars in total on the Ferris wheel. All right, the solution is simple. Remember this because it comes up a lot in different, disguised in different ways. You always divide 360 by how many little cars there are, or by how many little things. Like you'll have different questions, but it's a variation on the same theme, where you have a circle with a certain number of things on it, and the question is how many degrees does it have to rotate for the next one to take its place. So you just divide 360 by how many of whatever these things are, and that'll tell you the answer. Okay? So in this case, when you divide 360 by 20, you're going to get your answer, which is an 18-degree rotation. Every time that the wheel rotates 18 degrees, the next car will take its place. Okay, your assignment is in your student portal. It's 2.3 rotations, and it's due by 6 a.m. the next day that we meet. This concludes the lesson for today.